All right, semester 1, algebra 2, we're going to review for your midterm. Number 1, the only part of number 1 that I want you to focus on is what I have highlighted there: domain, range, increase, negative, and average rate of change over a specific interval. Okay, so let's talk about domain and range first. The domain, if you see my note there, it says that the domain are your x values, which are read from left to right. Think of a coordinate grid. Your x values to the left are negative, to the right are positive. And that's your x-axis. The range are your y values, up and down, because your y-axis travels up and down. Up is positive, down is negative. Okay, so your domain, if you look there, it is specifically written in interval notation with a parentheses, a negative infinity, and a positive infinity. I'm looking at this right here. That is your answer. Why is the domain negative infinity to positive infinity? Well, if you look at this graph, it never stops. If you're tracing it to the left, it never stops in the left direction. It continues. That's what this arrow means. In the upper left direction forever. And if I continue that, I'm going to be very dramatic here. It continues going left forever. And then in the right, this arrow means that it continues in the upper right direction. I'm going to be dramatic again, forever in the upper right direction. So your domain never stops left, it never stops right. So it goes left in the negative infinity direction and right in the positive infinity direction forever and ever, and it never stops. Looking at the range value, the range is from a closed 9 to a positive infinity. That means it stops going down at negative 9, which is right here. Negative 9. This point right here is at negative 9. Why do I use a bracket? I use a bracket because this is an understood closed point right here at negative 9. Remember, we're looking at the y value, negative 9. And then the graph covers in both directions, left and right. It continues forever and ever and ever in the up direction. So that's why it's infinity. Remember, infinity signs always are written with a parentheses around them. Okay, now increasing. Increasing means goes up. I have the note here, goes up from left to right. So if I want to highlight that part of this graph that goes up from left to right, it starts at this point and it covers all of this graph to the right direction here. This is goes up from left to right, okay? This is your x value. Remember, your intervals for increase, decrease, and positive and negative are all written with x value. So where does it start going up? At this point where x is negative 1. X is negative 1. 2, positive infinity, continues in the right positive direction for increasing. Decreasing, we don't care about it right now. I only want you to focus on increasing, but decreasing would be this interval, okay, because it goes down. The next one, negative. Negative means below the x-axis, below the x-axis. This interval, where did this negative 4 and 2 come from? That negative 4 and 2 come from right here. Negative 4 and 2. X is negative 4 and X is 2. Why did I pick those 2 points? Because the graph between those 2 points is below the x-axis between those 2 points. And again, negative interval is written with parentheses. You will never see a bracket in a negative interval or an increase interval. The average rate of change. Now, this problem specifically said between 0 and 2. So that is where this 0 and this 2 comes from. Those are your minimum x and maximum x value, 0 and 2. Where did this negative 8 and 0 come from? Well, this negative 8 comes from the graph, because where x is 0, here's my graph at negative 8. Where x is 2, here's my graph where y is 0. That's where that 0 comes from. This is the point 0, negative 8. And this is the point 2, 0. I use those because the interval given to me was 0, 2, where x is 0 and x is 2. So the average rate of change, you use the formula y2 minus y1 over x2 minus x1. So once I have those ordered pairs, label them x1, y1, x2, y2 like I did here. And put them in the formula y2 minus y1, y2 minus y1 over x2 minus x1. And you get 0 minus negative 8. Two negatives make a positive. 2 minus 0 is 2. 8 divided by 2 is 4. So your average rate of change is 4. Okay, I'm going to erase all this. All right. Looking at number 2. Number 2 is your piecewise function. Now, number 2 and 3 kind of go hand in hand together. I just gave you another little note down here for an additional problem that you can look at as an example. But if you look at number 2, the problem on your midterm is most similar to the number 2 graph here. And if you pull up the answer sheet on page 7, I'm going to scroll all the way down here on page 7. Here is your graph right here, okay? This is the graph that matches this rule here. So you see how I have 3 rules? In this graph, I have 3 sections. Section 1, Section 2, Section 3. So because I have 3 sections of my graph, I'm going to have 3 separate rules, okay? That's one point that would help you identify your answer on your midterm. The second point, see how I have a negative 1 here? Negative 1 between negative 5 and 6. Well, if you look at your graph, my graph is a straight horizontal line at x is negative 1. Y is negative 1 between the x values of negative 5 and 6. So as long as you know that 3 separate segments is the same as 3 separate rules, and that a negative 1, y is negative 1, is a straight line between negative 5 and 6, like you see here, straight line between negative 5 and 6. Knowing those 2 pieces of information will help you identify which graph matches to the rule. You're not going to have to graph by hand. You're just going to be given the rules and you have to match the graph, or you're given them graph and you have to match the rules. But as long as you know those 2 pieces of key information, 3 rules, 3 segments, a whole number is a horizontal line at that number between the 2 x values given, you're going to get that correct. Okay, number 4, we're going to state the transformations. Okay, for part B, subtracting inside, like we are here, subtracting inside is right. Adding inside is left. Adding outside is up. Subtracting outside is down. Now, I wanted you to focus only on a quadratic, meaning you had the parentheses with a square, because the equation on your midterm is a quadratic like here. You're going to see parentheses with the square, parentheses with the square. What happens on the inside? Remember, the value on the inside is left and right. If you're negative, you're right. If you're positive, you're left. And then outside is up and down. If you're positive, you're up. If you're negative, you're down. Okay, make sure you know those 4 rules. It's going to be a combination of 2 of those. Number 5, I'm going to zoom in here. This number in this position in the recursive definition is your first term. That is the term that you are going to write first when you're writing the sequence, okay? This number here, positive 4.2, if this is minus, then it's going to be negative. You're going to subtract. But this number here is what you're going to add to 8.4 to get your next term. Well, if I add 4.2 to 8.4, I get 12.6. Add 4.2 to 12.6, I get 16.8. Add 4.2 to 16.8, and I get 21. That is how you write the first 4 numbers of your sequence. All right, skipping on down to number 6. Use graphing technology and the intersect feature to approximate the values of x for which f of x equals g of x and round to the nearest tenth if needed. Look at this note here. Graph both equations in Desmos. The x coordinate of the intersection points is your answer. Why only the x coordinate? Because you are solving for x. You don't have x and y. You're solving for x. You're wanting to see, where do these 2 lines intersect? Where do these 2 lines intersect? So, looking at Desmos, I'm going to pull up Desmos. And this is how you're going to solve this problem. You're going to type in the first equation exactly how you see it. X squared plus 8x plus 5. There's that graph. Then you're going to type in g of x. To type in the absolute value, I'm going to have to move this around. Okay. Type in the absolute value. You're going to have to click the keypad. And then this button here is your absolute value. Oops, I'm on the wrong line. Here we go. This button here is your absolute value. type in x plus 2. And then outside plus 9. Type it in just like you see here, exactly how you see it in your question, okay? If you click and hover over the points, it'll give you the x and y intercepts also. So, and it'll also give you the vertex, okay? If you click and hover, it gives you the vertex, gives you the y-intercept, but right here specifically, it gives you your intersection point, okay? I have them both highlighted there. So the 2 points where those lines intersect, it says round to the nearest 10th, which is one place past the decimal point, negative 9.217, that is your x coordinate of the first intersection point. That rounds to negative 9.2. That 1 makes that 2 remain a 2. 0.772. 0.772. This second 7 makes this first 7 round up to an 8. So that's 0.8. So your 2 intersection points is negative 9.2 and 0.8, positive 0.8. So that is where these two numbers come from. Okay, you don't have to calculate anything, no algebra at all. All you have to do is know how to type in both of these equations in Desmos. I want you to practice that. Make sure that you can get these two answers. Same thing for number 7, 7A and C. Exactly the same way. Go to Desmos, type in exactly what you see. Negative 2x plus 8y equals 10. There's that line. The second equation, 4x minus 3y equals, oops, not 7, 6. There's that line. If you click and hover over the intersection point, you get 3, 2. Look at your answer, 3, 2. Same thing over here. Graph exactly what you see. The first equation, y minus 2x equals 6. And then y equals x squared plus 4x plus 3. Here's my graphs. Red line and blue line. They intersect at 2 places. 1, 8 and negative 3, 0. 1, 8, negative 3, 0. Now, make sure that these answers are written identifying the x and y coordinate as an ordered pair. Why? Because look at the equation. I have an x and a y. I'm trying to identify x and y for both of these equations where they intersect. So unlike up here where we were seeing where did these two lines intersect and we only wrote the x coordinate because I was only solving for x, down here I'm solving for x and y where these two lines intersect. All right, number 8. Tell whether the graph opens up or down, identify the vertex, find the y-intercept, and graph each using the information above. Well, to graph, use Desmos. Type this in exactly how you see it. So I'm going to go to Desmos. I'm going to type in exactly what I see in that equation. It's negative 3x squared minus 12x minus 5. There's my graph. So the first question, tell whether the graph opens up or down. It opens down. It goes up and then it goes down. This graph opens downward, okay? I have a vertex at the top and it opens downward. Identify the vertex. The vertex is this point up here. If you click and hover, it will tell you it's negative 2, 7. Identify the y-intercept. Well, if you click and hover, it identifies the y-intercept as 0, negative 5 as an ordered pair, or you can write that as y equals negative 5 like I did here. So it opens down, the vertex is at negative 2, 7, the y-intercept is at negative 5. You don't have to do anything here. All you have to know is how to type this equation in Desmos and then read the graph. Okay. Number 9, factor completely. Now on part A, I wanted you to actually solve. I wanted you to solve and find me the x value of this graph, okay? On part B, I wanted you to factor only and give me the 2 binomials. And part E, you're going to factor only. Okay, but part A, I wanted you to solve. So let me scroll down here because I did all this on a separate sheet of paper right here. 9A. If I'm wanting to solve for x, I have 1x squared minus 4x minus 32. What two numbers multiply to negative 32 and add to negative 4? Well, that is negative 8 and positive 4. Negative 8 times positive 4 is negative 32. Negative 8 plus 4 is negative 4. So I have x minus 8 times x plus 4 equals 0. set each binomial equal to 0. So x minus 8 equals 0, add 8 to both sides, x equals 8. X plus 4 equals 0, subtract 4 from both sides, x equals negative 4. Okay, so all you have to do is make sure that you multiply to your C value, add to your B value, where A is 1. Now, if you look down here at part B, you don't have to solve for x. You just have to factor, get my two binomials. See how A is not 1, A is 2? Well, that's going to change up a little bit because you need to multiply to whatever your AC is. 2 times negative 15 is negative 30. And then your B is still the 7. So what two numbers multiply to the negative 30? That's only, you follow these steps only if your coefficient in front of x squared is not 1. In this case, it's 2. So what two numbers multiply to negative 30 but add to 7? 10 and negative 3 multiplies to negative 30, but 10 minus 3 is 7. Now, when you set up your two binomials, it's not just x minus 30 and x plus 7. It's 2x, your AX, 2x plus 10 and 2x minus 3. Divide both terms in this binomial by 2 because they're even numbers and 2 factors into 10. So divide 2 by 2 and 10 by 2 and you get 1x plus 5. So x plus 5 times 2x minus 3 is what this trinomial factors into. 9e, you're going to use the difference of cubes. Difference of cubes, okay? So we are given a cube minus b cube right here. And this is what you're going to do on your midterm. You're going to have a difference of cube, okay? So this whole term right here, 64x cubed, that whole piece is your a cube. This negative is part of your formula. We can ignore it. So this whole second term, just the 27, is your b cube. So a cube, b cube, because this is a cube minus b cube. So if a cube is the whole 64x cubed, I need to solve for a. I need to know what a is by itself because that's what I'm going to substitute in here for my a value. To get a by itself when a is cubed, you're going to take the cube root of a cube. If I take the cube root on the left, I need to take the cube root on the right. So the cube root is 64. What number times itself 3 times will give you 64? You can also type this in your calculator. I believe, I don't have a calculator on my desk, but I believe it's math option 4 or math option 3. We'll let you type in a cube root. But what number times itself 4 times will give you 64? That's 4. 4 times 4 is 16. 16 times 4 is 64. And then the cube root of x cubed is just going to be x. The cube root and the cube exponent cancels each other out, and I'm left with 4x as my a value. Over here on the right, you can type this in your calculator exactly how you see it, or what number times itself 3 times will give you 27. 3 times 3 is 9. 9 times 3 is 27. So this is your a value, 4x, and your b value, 3. You're going to substitute that into this side of your equation. A minus b. A minus b. 4x minus 3. Then you are going to substitute your a and b into the second trinomial over here. A, where a is 4x squared, plus a, 4x, times b, 3, plus b, where b is 3, squared. That comes from this right here. I just substituted in 4x for a and 3 for b. Then you're going to clean it up a little bit. Of course, I can't change this at all. But 4x squared, you're going to square the 4 to 16 and square the x to x squared. So 4x squared is 16x squared. 4x times 3 is 12x. And then 3 squared is 9. And that is what your answer is. Okay, number 10. We're going to solve the quadratic by using the quadratic method. And the reason why you're going to use the quadratic method, if you look down here at the very, very bottom, you'll see that you end up with an imaginary number. So let's back up here. A is your coefficient in front of x squared. B is 9. C is 14. So if you use your quadratic formula, this will be provided for you. I will have it written on the board. If you use your quadratic formula and substitute in 9 for B, 2 for A, 14 for C, and 2 for A, and simplify, you'll find, down here, 9 squared is 81, negative 4 times 2 times 14, use your calculator, negative 12. 81 minus 112 is 31. You are going to replace a negative under a root. A negative under a root is always replaced with I. Okay, so your final answer is negative 9 plus or minus I root of 31, all divided by 4. And 31 is not a perfect root. There's no factor of 31 that's a perfect root. So you're just going to leave 31 under the root. Okay. Number 11, I'm just going to scroll back up here. Number 11. I have x squared minus 6x equals 12, and I'm asked to rewrite or complete the square and write the answer in x plus p cube, or x plus p squared equals q. Okay, so remember to find your new c value, okay, I'm going to add or subtract my c value by itself and only leave the two terms on the left. In this problem, I already have the two terms with x on the left with my constant on the right. So how do I find the new c value that I add on both sides? You're going to take your b value, that's negative 6, divide it by 2 and square. B divided by 2 squared. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to add 9 to my two terms with x and add 9 to the right to my 12. This is a common mistake right here is students forget to add your new c to both sides. Don't forget this step here. Now you have to ask yourself, what two numbers multiplied in positive 9 add to negative 6? It's going to be negative 3 and negative 3. Multiplies to positive 9 adds to negative 6. So negative 3, x minus 3 squared equals 21. Number 12, when you multiply two binomials, it's first, outer, inner, last. First, outer, inner, last. So negative 3 times 2 is negative 6. Outer, negative 3 times negative 3i is 9i. Inner, 2i and 2 gives you 4i. Last, 2i and negative 3i is negative 6i squared. Combine your like terms, 9 and 4i adds to 13i. I squared is always negative 1. Make sure you know I squared is negative 1. Negative 1 times negative 6 is positive 6. When I combine my like terms, negative 6 and 6 combines to 0. So I'm left with just 13i. Okay, number 14. Number 14, you're asked specifically about the discriminant, which statement is correct about the discriminant of this quadratic. So you're going to want to make sure that you move all the terms to the same side of the equal sign. So I'm going to subtract my 2x and subtract my 26. And this is my new quadratic set equal to 0. Identify your A, B, and C. The discriminant is the part of the quadratic formula. If I go over here, this part is going to be written on the board. Okay, your discriminant is what's underneath the root of your quadratic, b squared minus 4ac. That is your discriminant. Substituting your b value, your a value, and your c value, b, negative 2, squared minus 4, a, where a is 3, c, where c is 49, and simplify. When I simplify this, and you can type this exactly how you see it in your calculator, when I type that into my calculator, I get negative 584. Okay, that means that my discriminant is less than 0 and the equation has two non-real solutions. If the discriminant is less than 0, you have two complex non-real solutions, meaning your two answers are going to have an I in them, just like we did over here. My two answers are non-real discriminant. Okay. Make sure that you also review in number 14 and you understand. I would probably even make sure that I memorize these. If your discriminant is 0, you have 1. Greater than 0, you have 2. Less than 0, it's 2 complex non-real. Okay, I would make sure that you memorize those 3 just in case. Number 16, long division. I wrote that out also for you down here. Number 16, here is all the steps in detail. Okay, so make sure that you multiply your first term by the first number and follow this. I'm not going to go in this in detail and waste the time. Make sure that you can follow this along. If you need help one-on-one, I will help you one-on-one with this one because it's a lot to make sure that you understand. But here's the steps. Make sure you can follow along here, okay? Number 17, going back up to 17. All right, here we go. The factor theorem and remainder theorem, you literally do it the same way. You're just going to substitute in your A value. So on here, your A value is the opposite of what you see. If you have x minus 2, your A value is positive 2. So I substituted in positive 2 into this equation. 2 cubed minus 11 times 2 squared plus 16 times 2 plus 84, like what you see here. And then I simplify it. Type that in the calculator exactly how you see it, and you get 80. Is 80 0? No, 80 is not 0. So that means that this is not a factor. If you end up getting a number that is not 0, then that means it's not a factor. If you do the same thing with 6, you substitute in 6 and you get 0. Now this problem actually tells you that when you substitute in 6, you get 0. So is x minus 6 a factor? Yeah, because your A value is 6. And when you substitute it, you get 0, which means that it is a factor because you get 0. X equals negative 7 is an x-intercept of the graph. Just graph this in Desmos. I'll even do it for you. Go over here to Desmos and graph that into Desmos. Make sure that you know how to type this into Desmos. And that will tell you if your graph truly does have an x-intercept at that. Whoops, I don't know what I did there. There we go. Plus 16x plus 84. I need to take that sub out. There we go. Well, what is it doing here? There we go. Do I have an x-intercept at negative 7? Positive 7? Positive 6? Negative 2. Well, what did I do wrong? X cubed minus 11x squared plus 16x plus 84. Oh, that's my false statement. It's false. Why is it false? Because when you graph it, you get that your x-intercepts are negative 2, 6, and 7. You do not get that negative 7 is an x-intercept. Negative 7 is like way over here. You don't have an x-intercept there. So that's false, okay? So part A is false because I didn't get that P of 2 is 0. 6 is true because I did get that P of 6 was 0. D is false because if you use Desmos, you'll see that it doesn't go. And then the remainder, when this equation is divided by x plus 4, you're going to substitute in negative 4 for your A value. So negative 4 cubed minus 11 times negative 4 squared plus 16 times negative 4 plus 84. I just substitute in negative 4 for x, the opposite of what you see. And I get negative 220. Well, that's false because when I substitute in negative 4, I do not get 0. The remainder is negative 220, not 0. Okay, so that is also false. Okay, and then number 18, use Desmos. Type in exactly what you see. X cubed minus 8x squared plus 16x. There we go. Dun, dun, dun. What are your zeros? Your zeros are your x-intercepts. So your zeros are 0 and 4. 0 and 4. Those are your x-intercepts, also known as your zeros.